An essential feature of any modern pressure transmitter is isolation between the process fluid and the actual sensing device. To illustrate this, we're going to take a look at a cutaway of a Rosemount 3051S differential pressure transmitter. And I'm going to walk through how this is isolated from the process fluid so that the potentially dirty, corrosive, viscous process fluid does not have to come up and actually touch the sensing element itself. Here, the sensing element of this transmitter is this object right here. This cylindrical object, you can see it from the one side here, it's cylindrical in shape. There's a thin metal sensing diaphragm in the middle that gets pressed to one side or the other by a difference in pressure applied to that sensor. That movement of that sensing diaphragm is detected by a couple of stationary metal plates using the principle of capacitance. As the moving diaphragm comes closer to one plate, it increases capacitance and decreases with regard to the other plate that's now further away. However, this is only reliable and repeatable if the fluid inside this sensing element right here has a constant dielectric permittivity. And that would not be the case if we let any old process fluid up into this sensor. And so what they do is they isolate the process fluid with a pair of isolating diaphragms. Now, this particular model of transmitter, this particular cutaway, I should say, not the model, but this particular example transmitter, we have the isolating diaphragms removed. But normally the diaphragm would be roughly the same size as that circle, and it would cover up that tiny little hole you see right there. And behind it, you would have a clean fill fluid, usually a silicone compound, that would flow up into that tiny little hole through a capillary passageway into the sensor, so that when process fluid pushed against the isolating diaphragm would flex and transfer that pressure to the clean fill fluid, the silicone fill fluid going inside the tube up into the sensor. As I said, these diaphragms have been removed for the sake of the cutaway, but they would normally reside right here. So without the diaphragms in place, you can see the tiny little hole where the fill fluid goes from the backside of the isolating diaphragm up to the sensing cell itself. The choice of this fill fluid is important because there's always a potential for the isolating diaphragms to rupture or leak, and you want to make sure that your fill fluid is compatible with the process. Say, for example, if you're measuring the pressure of pure oxygen, we know that pure oxygen greatly accelerates combustion, and so we would not want to have a fill fluid in here that was combustible. We would want to have something that was fairly inert, that would not react with pure oxygen, and so they make fill fluids for that application. Or let's say we were in an application measuring pressure for food processing. We would want to make sure that if the isolating diaphragm ever ruptured or leaked, that the fill fluid would not contaminate or make the food unhealthy in any way. So they have fill fluids for that as well, usually glycerin-based, food-grade glycerin or food-grade oil. And that way, if there is ever a leak, it's not going to harm the process. But as I said before, every modern pressure transmitter has some sort of fill fluid inside to hydraulically isolate the sensing element itself from the process fluid that you happen to be measuring the pressure of. And the Rosemount 3051S is no exception.